Hello, this is Ms. DB. In this video, we are going to graph using intercepts. So we're going to find the x and y intercepts of a line from a graph and from an equation. And then we'll also graph some lines using intercepts. First thing up is standard form of a line. In the last lesson, we used slope-intercept form of a line. This is standard form. It'll look like ax plus by equals c. Of course, any of the coefficients a, b, or c could be negative, so that would change the signs. Next, we're going to look at the y-intercept and the x-intercept. So the y-intercept is where your line crosses the y-axis. The value of x right there is 0. So this point would be 0, 8 written as a coordinate, or you can simply say that the y-intercept is 8. The x-intercept is where the line crosses the x-axis. The y value at this point is 0, so we can say that the coordinate of the x-intercept is 6, 0, or we can simply say the x-intercept is 6. On the first part of your worksheet, you're just going to name the x-intercept and the y-intercept from these three graphs. Note that in number 2, the x-intercept is not at -4. You can make these bigger if you need by just, whoa, that got really big. But you can see it's actually to the left of -4. So that's kind of a common mistake. So I wanted to alert you to that. All right, now we're going to look at equations of lines. These are lines that are written in standard form, and we're going to find the x and y intercepts using substitution. Remember that the x-intercept always has a y value of 0. So it'll be something 0. The y-intercept has an x-coordinate of 0. So it'll always be 0 and then whatever the y value is. And we're going to use that to solve these problems. So here's an example. We have 3x minus 2y equals 12. So to find the x-intercept, we are going to rewrite that equation, but instead of y, we'll put 0, because that's what y is in the x-intercept. It's always going to be 0. So now we get the equation 3x minus 2 times 0 equals 12. 2 times 0 is 0, so that simplifies to 3x equals 12. Now we just divide both sides of that equation by 3 to get x by itself, and our x-intercept is 4, or if you want, you can write that as 4, 0. That's totally whichever way you prefer. Then to find the y-intercept, we're going to replace x with 0 and solve for y. So we rewrite the equation again. We replace the x with 0, and 3 times 0, of course, is 0, so we're left with -2y equals 12. Then you divide both sides by -2 to solve for y, and we get y equals -6. You can leave it just by writing that the y-intercept is -6, or you can write it as a coordinate point, which would be 0, -6. I also put a Desmos, pre-made Desmos sketch right here that you can use to check your intercepts. So I have that open. Let me show you what that looks like. So here's the general form, ax plus by equals c. And you can use these sliders to adjust to match your equation. So our equation was 3x minus 2y equals 12. And I've already set them to be 3x minus 2y, because it's -2, equals 12. I did have to change this. You can do that. You can change these to higher numbers by clicking on the number at the far. Now I've changed that one so that you can slide all the way up to 12. And that one I already changed. And this one I didn't change yet, but I didn't need to, so I'll just leave it like that for now. So now I can slide them farther. And then I also had to turn on the labels so that I could see what the intercepts were. So I got intercepts at 4, 0, and 0, -6. So my x-intercept was 4, 0, and my y-intercept was 0, -6, which matches exactly what I got, so that's how I could verify that my solution was correct. So you're welcome to use that if you want. You don't have to, but it might help you check your work. All right, then you're going to do the same thing for 5, 6, 7, 8, and 9. You're going to substitute in 0 for x to find the y-intercept, and then you're going to substitute 0 for y to find the x-intercept, whichever order you want to do those in. And then the next section, there's another method called the cover-up method, where you basically cover up part of the equation to find one of the intercepts. I'm going to get a small shape here so I can show you what that looks like. I'm just going to insert a square or something. There we go. We've got a little square. It might be a little big. You would just do it with your finger, covering up your finger on the screen. All right, so to find the x-intercept, I would cover up the whole part that shows the y. So 5x, ignore that minus sign, 5x equals 15. And then if you need to, you can write that equation, but you can probably solve that in your head. That means that x is equal to 3, so the x-intercept is 3. Then you would move this over and cover up the x section. Now make sure you see that that's a minus 6y, which becomes negative 6y. So we have negative 6y equals 15. Now that's going to be a fraction, but that's okay. Intercepts can be fractions. Negative 6, negative 6. So y is equal to 15 over negative 6, and I could divide both of those by 3 to get a simpler fraction. 15 divided by 3 is 5. Negative 6 divided by 3 is negative 2. So my y-intercept is negative 5/2. Or you could write that as negative 2.5 if you prefer. If you had used your calculator on 15 divided by negative 6 instead of as a fraction, you would have got negative 2.5 right away there. See? All right, so you're going to you can use that method on these to practice. And you can still check them at that calculator site. And note that quite a few of these you'll get a fraction, and that's okay, a fraction or a decimal. If you do get a decimal, don't just round to the nearest tenth. Write out a few decimals or round to like the nearest hundredth or something, just so we're not rounding too much. And it's also okay to have, like in number 13, let's look at this one. We have negative 1.3y equals 12 to find the y-intercept. So when we solve this, we would be dividing by negative 1.3. And for that, I certainly would get my calculator out and have 12 divided by 1.3, negative 1.3. And see all those decimals? What I'm saying is don't just call this negative 9.2. Let's call this negative 9.23 because the digit after that is 0. So negative 9.23. Was that the y-intercept? And there's another one at the end there. All right, and then for these two problems, use any method you want, and then you're going to find the intercepts, and then you're going to graph using the intercepts. So I want to look at one of these because that's something a little bit different than we have done before. Let's do 15 because that one's not written in standard form, so it's a little different looking. But we still do the same thing. To find the x-intercept, you let y be 0. And that means that we need to, this looks funny, I'm going to subtract the negative 3 to the other side. So now I have negative 3 equals 2x. Divide by 2, and I get x equals negative 3/2, which is the same as negative 1.5. It might be easier to graph that as a decimal. So my x-intercept is at negative 1.5 right there. Now I'll find the y-intercept. I'm going to find the y-intercept by letting x be 0. So 2 times 0 plus 3. So the y-intercept is just 3. Y equals 0 plus 3 simplifies to y equals 3. I don't have to do anything else. So I go up 1, 2, 3, and I put a point. Now you draw a straight line through those points. Don't just stop at each point, go through them. I'm going to get a line shape because I can't draw straight lines very well. And I'm going to go up through the point, and then I'm going to come back here and extend this way so that I'm going through the point like that. So that would be for number 15. And then 16, you'll do similar. You'll find the x-intercept and the y-intercept, and then you'll graph them and draw a line through the points. You can use Desmos or Sketchpad or GeoGebra to make these graphs rather than doing them by hand or using these word tools. That's fine. The questions at the end are some word problems that are related to finding the intercepts of lines. They are optional. They are worth a little bit of extra credit if you decide to do them. Thank you very much and have a wonderful day.